Now, the whole concept of today's talk, especially at the COVID situation, is that, I've been talking about it for quite some time. What are our basic needs? Our basic needs is that we want to have a healthier life. We want to live in a very healthy life we want to have. We want to have a very clean environment. We want to live in a clean atmosphere. And then we want to live in a safer atmosphere. These are what are our considerations are these. Our environment should be healthy to live in, clean to live in, and safe to live in. How are we going to connect that with the analytical instrumentation? That's the topic going to be today. So the analytical instruments really add the quality to your life at any time, day in and day out, whether you are awake or asleep. There are people, analytical instruments are working, analytical chemists are working. And we are concerned right when the time that you turn on the tap water, right when you squeeze the toothpaste, right when you use the soap, shampoo, conditioner, right when you use the hair. These are all the real which affects our body, affects our body, and we are very concerned about the quality and safety of these type of products. And then about your dresses that you wear, whatever azo dyes are present, are there azo dyes are there any carcinogenic substances in whatever we wear, and is there any dangerous chemicals in the spray that we use, perfume spray that we use, the footwear that we wear, and when we eat our breakfast, how safe it is to eat our food that we have and the beverages we have, and when you take your medicine, is the medicine very safe? What are the how they are made the medicines, what are the quality steps that they are taking, what is the care that they are taking in making these medicines. These are our concern. And even when you go to the car, you are worried about what is the quality of the petrol, what is the quality of oil that you use in that. So every step, even when you take the last pill, whether you take it or not in the night, you are always concerned about how safe we are, what is the quality of the substances or the things around that we have. So again, one of the main things that we have is the water. Water all around us. Is the water that we drink safe? Is the water flowing in the river safe? What are the chemicals that are in that? And how is the sea? Can we go and swim in the sea? Is the sea safe enough for us to swim? And these are anything connected with the water, we are very much worried, including the rainwater. The rain is going to start. I can see the drizzle already. And when the rainwater is coming, we are going to see whether how safe is the rainwater, what are the acids it is bringing down, etc. What is the dust it is bringing down, and where is it flowing through into the lakes and rivers. And similarly, air around us. Right now, the air around us is very safe because the number of automobiles and some of people driving is very less, and the industries are also partially working. So the air right now that we breathe around us is quite safe and good compared to what it was previously. But then what are the things that you should be worried about? And soil where we cultivate, is it safe? What are the chemicals in this? Or where we construct a house, is there some chemicals that even buried underneath? I remember in Thana Belapur Road a few years back when people wanted to buy it and construct some houses. When they dug the soil, they found drums and drums of chemicals. So these chemicals really seep into the soil. They really leak into the soil and spoil the whole soil there and also the water beds underneath. So we have to be extremely careful about this. And are the milk and beverages that we drink safe? Now milk especially, because I will show the type of additives that they use in milk. So we have to be very careful. And as chemists, we understand what this is, but we have to be aware of it constantly. And are the fruits and vegetables that we eat safe? That is very important. What are the type of pesticides? What are the type of things present in that? Okay. Other than the insects and other things, that is different. But coming to the chemicals. And are the chicken, meat, seafood, etc. safe? I will talk about these things today in order to bring you very conscious about it, especially those students who are not aware about it. When I go to any colleges and give the talk, they can say, wow, we never knew about it. So that is the situation that we wanted to share with the people who are really interested to know about how safe it is to eat all these things. And are the waste we create, actually you can see, and industries can safely handle, treated and disposed. You can see how much of municipal waste that we create every day. Everything that we create, the human beings, whether it is in Bombay especially, we create lot of waste. Leave aside industry waste. Per head that we create lot of waste, including the human waste. How are these being handled? And these are the things which is coming back to us as various viruses, various things, various bacteria, what is in the water, air, etc. So we have to take care of these things very well. We create these problems to ourselves. Now, what are these compounds we are talking about? They are organic compounds generally containing carbon, hydrogen, oxygen, halogens, phosphorus, etc. So we have, and also there are inorganic compounds containing alkali metals, potassium, sodium, iron, etc. And also heavy metals such as copper, lead, mercury, iron, arsenic, etc. etc. And also organometallic compounds. Now, how do we analyze these compounds? How do we know this? Okay, all around our nature, okay, they can be pollutants, there can be problematic compounds present. How do we identify them? How do we look at them? How do we isolate them? How do we identify them? And there are these techniques that come in, that is column chromatography, thin layer chromatography, including HPLC, paper chromatography, gas chromatography, liquid chromatography, supercritical fluid chromatography, capillary zone electrophoresis, ion chromatography, etc. Now, in this, except this, a little bit about supercritical fluid chromatography and capillary zone, this we are not going to talk, but every other thing somehow or other we'll be covering in all that. Maybe in the general introductions, thin layer and paper chromatography will be covered. But most important we are going to cover is gas chromatography, liquid chromatography, and hyphenated techniques, GC-MS and LC-MS, and ion chromatography, which is very much used in cation and anion identifications. And when you go to the electromagnetic spectrum, this is very good. If some of you have not written it, it is available in the internet, you can download it. And what it shows is that the wavelength, which is going from right from picometer all the way into really in meters and kilometers. And if you see them, they are from very, very small sizes. It starts from here, which is gamma rays and X-rays, soft X-rays, and this is the UV ultraviolet, visible range, infrared, then microwaves and radio waves, etc. We are using them very much. Radioactive substances are here, then visible lamp is here. This is the, we are living here, this is our visible region, and then radio waves, all our mobiles, etc. They work in these conditions, and you can see, if you see the wavelength, they go from here, right from angstroms all the way up to a field, football field. That is the type of wavelengths. And the wavelengths with the least amount, the smallest wavelength have the highest energy, as you know. And if you go to longer wavelengths, then they have less energy. That's why this type of radio waves and other things are not really causing much harm, though there is always discussions about it, that these things do harm to us. So it is better to be careful about it. But definitely, as you know, if you are having gamma ray, X-ray, etc., they are much more harmful to us than the larger wavelengths. So this is a very good one, which gives you even on the frequency scale, energy scale, etc. Please print it out and then put it in on your wall so that you are familiar with it almost every day. So when you have spectroscopic techniques, then you have atomic absorption mainly for metals, indirectly coupled plasma, etc. for metals, ultraviolet UV visible for organic compounds and some inorganic compounds, Fourier transform infrared again mainly for organic compounds, nuclear magnetic resonance for proton and carbon-13, and then you have mass spectrometry. And mass spectrometry does not come into the optical this one. It is a separate one, works on the ionization technique. I'll be impressing upon this too much on during this week. All this you can say they come into the electromagnetic spectrum region, but this one this does not appear in the electromagnetic spectrum, and that is mass spectrometry. And then you have hyphenated technique such as GC-FIDR, GC-MS, GC-MS-MS, etc., LC-NMR, LC-MS, LC-MS-MS, then IC connected to the mass spectrometer. Narendra will be talking about it on Saturday, and ICP-MS, again inductively coupled plasma, OES being connected to mass spectrometer. These are very, very powerful. And these hyphenated techniques, when you connect a chromatography equipment to a mass spectrometer, then it becomes really a very good qualitative analysis, like you can determine what it is, and also you can determine the quantitation you can do very well. So very sensitive technique is mass spectrometry, and then other techniques. So we'll be covering quite a few of these detectors, etc. during our talk. This is the laboratory I wanted to talk about. When I am talking about this building up of the laboratory, and I am some of the people involved with this, like Jayanti Ramurthy, etc. are the people who involved with me in this building up of this laboratory here. I'm very proud of this laboratory, and we built it up in the year 2013, and I left in 2018, and it is still continuing. And for the 5 years, we did a lot of training here, and I will show you some of the instruments which are there, all very, very modern instrumentation which are here in this laboratory. And you can see the gas chromatograph here, very leading brand gas chromatograph. Gas chromatograph connected to a mass spectrometer and to an autosampler and to a headspace analyzer. Why I am showing, please remember these things because this will be covered by Dr. Datta tomorrow, but then he may not be able to have time to talk about these activities with these accessories, but he will mention about it. So the mass spectrometer, as you can see, and much smaller than the GC, and this is an autosampler. And this unit that you see here is very important, and that is the headspace unit, and which is connected to the injector. And we will be talking about it. Even today, I'll be talking a bit about how GC with the headspace and GC-MS with the headspace will be used. So please pay attention to that part. And here you can see that we have one quaternary HPLC here and then another HPLC. So we had two HPLCs. So we could provide a lot of hands-on training to that. If I said to you that a few hundred chemists trained here for days together, hands-on training, and that will not be a lie that would be telling. And many teachers, more than 100 teachers have trained here in their all the instrumentation, and they are able to go back to their department and teach students further. And what you see here is an FTIR with all the accessories present, so we can do things very quickly, and a very nice UV spectrophotometer, which is also very powerful. This is the ion chromatograph that you will be hearing about it on Saturday. Do not miss this lecture. You will be able to do the cation and anion, and the importance of ion chromatography is very much today in the analysis of even in the food and water and so many other applications, both for cations and anions. Well, this is not from the laboratory, but this is some pictures that I wanted to show you. This is the atomic absorption. As you can see, they aspirate the sample and you burn the sample, they form the ions, and you analyze in atomic absorption. And this is the ICP OES, which is much more expensive than that. You can do simultaneously a lot of elements. You can do a few elements simultaneously from here also. And this is the NMR. And this is a superconducting NMR. Many of you who have used NMR, you will know that. You will drop the sample here, and this is the electronics console, and from here you can control the entire system and do your NMR experiment from here. And this is the mass spectrometer, HPLC connected to a triple stage mass spectrometer, and we will be talking about it on Friday. And so you have to bear with us for a few days now. We'll be talking about the LCMS. Sharing with you a picture of Michael Sweat, who really initiated in the early part of last century. In fact, his experiment started in year exactly 1900, and 1901 for the first time he reported about chromatography. He is a Russian botanist, and he separated some of the pigments that is present in the plant material, and he did that by chromatography, by column chromatography, and that is how the whole world started with chromatography right from Michael Sweat. In 2019 he died. 1919 he died. He lived a very short life, and he did not win the Nobel Prize because he was nominated for a Nobel Prize in 1919, but unfortunately he died before he got the Nobel Prize. But otherwise he would have been the first person to win Nobel Prize in chromatography. But tomorrow Dr. Datta will share with you how many Nobel Prizes have been won in chromatography, and I will also share with you some of the Nobel Prizes won in mass spectrometry later on. So just to give you one slide where what are the type of chromatography we are talking about. Now many of you are very familiar with column chromatography. This is what Michael Sweat started, and you can have he did it with the calcium carbonate, and he started with the petroleum ether, and now you have a lot of things like silica gel, alumina and whatnot, and you load your substance and have your liquid solvent front here, and it will separate your compounds, and you can collect the fractions and you can analyze them, which are the components present in your mixture. So that is column chromatography. That is a liquid solid chromatography, and that works on adsorption principle. So there will be two principles that I will be talking today in brief, and that will be in detail later on. And one is adsorption chromatography and another is partition chromatography. And when we go into GC and GC-MS, LCMS, you will be talking more about partition chromatography and not about adsorption chromatography. But if you go to the planar chromatography such as TLC and HPTLC, you will find that it is silica gel or any adsorbent which is coated onto a glass plate, and it is two-dimensional. You will put your your substances here, and you will run in a mobile phase. Again, this is a solid which is an adsorption medium, and your compound adsorbs here. Depending upon its affinity, the compounds will move. So this is also based on adsorption chromatography. And there are partition chromatography, which is really here gas liquid chromatography and liquid chromatography. I will come to paper chromatography later. Now, in the case of gas liquid chromatography, if you are talking about really most of the chromatography today, gas chromatography is done on a gas as the mobile phase and non-volatile liquid as a stationary phase. So your compounds undergo a partition between a stationary liquid phase and a mobile gas phase. So it is actually called GLC, which is gas liquid chromatography, which you have abbreviated as GC. And when you go to liquid chromatography, then what you have a liquid non-volatile liquid or very high boiling liquid which is coated onto a silica gel or which is bonded to a silica gel, and that makes us the stationary phase, a liquid stationary phase. And then you have mobile liquid, which is the mobile is a liquid phase also. So what you have is a liquid stationary phase, and a liquid mobile phase is actually liquid chromatography, which we call liquid chromatography LC, and high pressure liquid chromatography as we apply a larger pressure. So that is in simple about partition chromatography, very important. And Dr. Dattara also will explain to you about gas solid chromatography, which is on adsorption principle, but that is a very small amount of application today. And then when you come to paper, most of the people in the planar, they think that paper is solid, and then we are putting it, so loading the sample here, it is separating. So we are putting it on a solid, so it should be adsorption chromatography. And the most important thing that I wanted to talk about this is that it comes in the partition chromatography. The principle of paper chromatography is partition chromatography. So you may ask, what is the stationary phase, liquid stationary phase? Very interesting that it is the water molecules present in the cellulose. The water molecules present in the cellulose. Once again, I will repeat it. The water molecules present in the cellulose act as a stationary phase, liquid phase. And then your solvent moves. So it is a liquid separation, partition separation. So paper chromatography also comes under partition chromatography principle. So this is very important for you to understand these two principles, adsorption chromatography and partition chromatography. We are going to build upon our complete seminar on this particular slide for the next few days. Just to give you a little bit more idea about it. So if you have a stationary phase and you are putting onto that a mixture which is represented by the square and the triangle, and the mixture of two substances are loaded onto any column, any methodology, then they get separate according to their polarity, and that is called retention time, and this is the detector signal or absorbance, or you can say that it is the intensity or the presence of the amount of substance. You can say the abundance. So here what happens is, if you are talking about a GC, then you will see that you get the two peaks here nicely, you get the two peaks. Okay, if you are doing TLC, you may get two spots, but if you are getting GC, you will get the two peaks, and the first peak which comes here is the first non-polar compound, and this is the little more polar compound. Less polar compound and more polar compound will be the right nomenclature for me to tell, and this is called retention time, and this is the quantity, and the area under the peak will give you an idea about the quantitation. So this is a good qualitative technique and quantitative technique. Qualitative technique provided you have standards. This will be explained to you tomorrow why you need standard in the identification in the case of GC. And when it comes to GC-MS on Wednesday, I will talk to you how we can identify them even if I don't have a standard. So that is the beauty about all these type of different instrumentation capabilities. So please remember, this is very important. It is not just a separation of the two peaks. There is a lot of principles and chemistries involved in it. The type of columns that you select, looking at the type of compound you are going to analyze, what is the type of column that you want to use, what is the type of stationary phase, what is the type of mobile phase, etc. that you need to use. So it is very important for you to understand this. A block diagram of a basic GC system. Dr. Dattara will be talking a lot about it tomorrow. So you have a gas, this is the mobile phase gas, and it comes to a GC where you have an injector, the column which is the heart of the analysis, very important part. Then you have a detector. Now you have different detectors, RFID, TCD, etc. He will explain to you tomorrow. And instead of that, if you have a mass spectrometry detector here, it becomes a GC-MS. Okay, so that is very simple, converting a GC to a GC-MS, then put the mass spectrometer next to it, and that becomes your GC-MS. But remember, your mass spectrometer is going to be much more expensive than a GC. As a detector, much more expensive than an FID or TCD, etc., many-fold than the price of a GC. But the advantages are much more, and that you will get in the lecture of GC-MS. HPLC same way. I am not going to go through the details because Deepak Vellani is going to talk very nicely about it. He has excellent slides also. So there is a pump, sample injector, column oven detector, etc. So that makes a whole system of HPLC. When you come to GC-MS, then you have the GC where the separation takes place and it goes through an interface to a mass spectrometer. This will be dealt in detail, ion source analyzer and detector, and then you have a data system and a high vacuum pump. So GC does the separation and mass spectrometer does the analysis of each component that is going into a mass spectrometer. So here you must remember basically that gas chromatography is the separation technique and mass spectrometer is the identification technique, and then you get your mass spectrum. This is going to be an extremely interesting talk both about the GC, GC-MS, LC-MS and ion chromatography. So if you can join us every day, we will be very happy and you will be very happy. Now, one of the things I have done is that I'm a strong believer that whether you are doing an academic research or whether you are doing in an institute or whether you are doing in an industry laboratory, one thing I have done is that I have drawn a chromatography axle. Because I tell people that the industry revolves around the chromatography axle. So that is why I created this slide to give you an idea. So if you are working with any organic compound, you are analyzing any organic compound, let's say pharma, then pharma you can put as one wheel which is rotating around the chromatography axle. If you are working on essential oils or edible oils, then you can put it across here. Edible oil you can put as a separate wheel if you wish. Food and beverages, if you are working, you can put it as a separate wheel. Petroleum, petrochemicals as a separate wheel. Environmental, whether it is air, water, then sludge or whatever you say, that can soil, anything can come under environmental. And so this is a chromatography axle. You can have a spectroscopy axle also if you want, but mainly interesting, you can consider this as a chromatography and spectroscopy axle because chromatography is connected with the spectroscopic technique. So I can even name this as both a chromatography and a spectroscopy axle. I don't have to be very biased to call it as a chromatography axle. Maybe I will change it into a chromatography spectroscopy axle. So some of the application areas I am going to talk to you from now till the time permits me. And you can see the petroleum, whether right from the exploration, all the way the entire value chain of the petroleum industry, then you have a lot of GC, GC-MS, HPLC used. But this is one industry that where you are working more with the volatile samples. And when you are working with the volatile samples, then your number of GCs will be used more and less number of HPLCs. So when you go into a petroleum petrochemical industry, you will find they have a lot more GCs compared to an HPLC. And you have online GCs also. So you will have directly 24 hours working that takes an L1 from the industrial, from the main line, and it will be continuously analyzing it. So it will know what is coming right from the crude oil. You have to know what is the crude oil quality. And you can use a GC with a sulfur analyzer to find out how much of sulfur is present in that. The quality of the oil is determined by sometimes the percentage of sulfur present in it. So right from petroleum exploration to crude oil to refinery gas analyzer, hydrocarbon analysis, natural gas, everything, and whether when you are going to synthetic plastics, monomers, etc., you have to have a lot of GC and GC-MS and whatnot. So we are going to talk about those things in the coming days. When you come into environmental, as I told you, environmental mainly talks about 3 areas or 4 areas, which will be one is air and drinking water and wastewater, which is drainage water, industrial effluents, etc. All those things will be, and you can say that the water which are present in the lake, etc., they are also a part of the drinking water. Okay, so all the water bodies that we have to analyze, even if it is a well water, we have to analyze them because there is a seepage of chemicals through underneath the soil that can get into your water, and that can be very dangerous. And the wastewater, the drainage water, industrial effluents that we create a lot of wastewater, all those things are drainage, and that is all comes under this. And the amount of detergent that we put right from our bathrooms and right from our kitchen and all the washing materials, you can imagine the amount which is coming out from each and every house in Mumbai. And leave aside other cities, just in Mumbai, if you take, they will be in megatons. And all this is ending up somewhere in the water. And then how do we really purify this water is the challenge. We use a lot of soap, we use a lot of other materials for washing for our own body, and then all these are ending up in this drainage water. And solid waste, sludges, etc. from the industries mainly. A lot of chemical industries produce all these things, and we create a lot of solid waste, but they are all containing a lot of chemicals. So they all end up, all the medicines that we eat, where do they end up? All these antibiotics, all this other medicine, what is defecated, they all end up somewhere as solid waste. So if you really analyze in a day what is happening, if you take about 5 minutes or 10 minutes or 15 minutes of your time and sit in a corner and think what is happening in a day, you will be amazed. Then my lecture will make much more sense to you in the coming days. Now, what are these compounds in the application of agriculture and livestock? This is very important for me to cover here. Analysis of phosphorus and halogenous pesticides and herbicides. Herbicides are for killing the grass, etc. The compounds are called herbicides, and pesticides also for killing a lot of pests. And unfortunately, what happens is that the pesticide residue is increasing every day in the plants because the farmers use much more than. If they are told that you use 1 gram per liter, they think it is better to put 10 grams per liter. And they spray it, and then there is a lot of these extra pesticides that get around the trees, get around the plants, get around the fruits everywhere. So if you take the fruits and vegetables sometimes, and also things like fruits such as grapes, you will find a lot of white dots on them if you really examine them. And you will find that they are all nothing but a lot of pesticides which are sprayed onto them. There are also pesticides that get into a plant and material through what is called systemic pesticides, that is coming from the soil, going through the water. But fortunately, they cannot travel too long to a tree. So if you are taking a fruit or a vegetable from a tall tree or from a long creeper, then you are fine. But if you are taking something like a palak or something like cauliflower and cabbage, etc., they don't have long shoots. We have to be very careful whether the systemic pesticides are getting into this. From the soil, they can enter into this material, into these vegetables and fruits, berries, etc. So pesticide residue and colors in food and beverages are very important. A lot of food that we eat a lot of coloring materials. Children love the colors. They love the red color, green color, blue color. But what are these? Are they edible colors that we are using? How they get to, what is the pharmacology of this? Are they going to stay in the body? When are they going to excrete it? Are they going to decompose? These are the type of things that we should really worry about it. Now, a few years back, you remember that big case, Coca-Cola was identified that it has got a lot of pesticides in that, more than what is permitted, and it was banned, as you know. They came out of it after doing all that. And lead in Maggie, these are the type of things, you know, though it is a metal and not a pesticide also, it is also causing a lot of problem. Now, the thing is that even the toys which used to come from China, they used to have a lot of lead dyes in that, and the children used to put in their mouth. Now, if the parents are not aware that this contains lead, then slowly the child is going to get a lot of lead poisoning. So first of all, it is very important. Now, at least the washing of the hands has become very, very popular now. Everybody is washing the hand every minute now. So that is in a way good. Similarly, if you are not allowing the children to put all these things into their mouth, I think that will be another important step that we should be taking. Do not allow them to put any of these things into their mouth, especially the toys, clothes, etc., because they are all impure things. Commodity inspections, adulteration of species, spices such as chili powder. I remember many, many years ago, the natural chili powder that we were getting, that was mixed with a red dye, which was called gongo red dye. If we didn't analyze them, then we would have ended up eating a lot of these azo dyes in our food. Imagine you are a chemist that if you mix with nitroanions are so cheap, turmeric is expensive natural product, and mixing nitroanions with turmeric, that can be very dangerous. Milk products in the milk, that they always look at nitrogen content, gel, and they say the milk is good, the quality of it, depending upon the nitrogen available in that. And in China, a few years back, you remember, they really mixed with the triazine. Triazine is a six-membered ring with a 3 nitrogen percent. So the number of nitrogens are very high in that. And also imagine urea that also contains nitrogen. If they mix this type of compounds in the milk products, then that becomes very dangerous for us to consume. And continuing with that, a few years back, when China arrested those people, 2 or 3 people who were involved in that, and they were executed within 1 month. Once they identified that these are the people who did it, and they confessed to that, then they were immediately executed within 1 month. So they were not kept in the prison for their lifetime. Stored nuts and grains, very important, again, aflatoxins. If you remember a few years back in Bihar, some of these little children in the school died eating some of the nuts, and they were mainly made the food made out of the peanuts, which had fungus, and that made aflatoxins. So these fungus are capable of making aflatoxins, which are extremely toxic. And aflatoxins are analyzed today by HPLC with the fluorescence detector. And many of our food laboratories have got this setup of HPLC with the fluorescence detector. This is very important. Presence of antibiotics, nitrofurands, steroids, etc. in poultry and meat. Now, for example, people use sometimes steroids in the chicken farms, and the steroids are anabolic steroids. The biggest problem with anabolic is that it grows the chicken into a big size, and chicken is sold by weight. They will go and point out to that big chicken, I want to buy that. But we don't know whether in what has cost for it to become so big. It could be anabolic steroids, and the steroids remain in the chicken, and we eat them. We will also start growing our muscles and all that. If we grow the muscles, it's okay. But the problem is if we start becoming diabetic patients. That is the problem. And similarly, antibiotics, nitrofurands, etc. Lot of these chickens and other things, they become very sick. So in order to avoid the sickness, they give antibiotics in full amount. And if they require only a small amount of antibiotics, people think it is better to give, because they are not all the people very highly educated. The veterinarian will come and say, okay, inject this into them, but they will inject more amount, and the antibiotics reminds them an extra amount, and this cannot be washed away, and we consume the antibiotics. So with the antibiotics, what happens? All of us know that our immunity comes down. And that is why doctors say that they are very reluctant to give you antibiotics, because antibiotics will make your immunity go down. So that is one thing that we have to be very careful. This is a very important thing, sodium nitrate. I was wondering why they add sodium nitrate to sometimes onto the meat, and that meat looks very red once you put sodium nitrate. But the problem is that once you broil, once you heat this meat, then if sodium nitrate is present in it, then that combines with all the other things present in the meat, and then they form something called nitrosamines, and the nitrosamines are extremely carcinogenic. That's why we don't take any burned food. We avoid a lot of things, whether it is vegetable or meat or anything. We don't like it to burn, become charcoal type, and that is because we don't want the carcinogens, and they are sometimes carcinogenic, many a time. And the toxic organics and metals in fish, oysters, crabs. This happened many years ago in Japan, that some industry they send their which contains mercury into the sea, and the oysters and all that had it, crabs, and the mercury ended up with the people, and the children became really crippled and all that. Very sad stories that you can say. And also these pesticide stories in Kerala. What type of pesticides have been used, and how they have got the children have become very malnutrition, and how really deformed their hands and all that. So these are important. But the indiscriminate use of these things are a big problem for us. That is what is our man-made problems today. So we have to have the understanding about it. We have to ask questions: what are you using, how much you are using, etc., etc. Edible oils, very important. Can you imagine the amount of oils that is being used in India? People are buying, I have seen 10-liter bottles, 20-liter carboys, people taking it, and that is one of the main things that they buy from the store. And this edible oil, can you imagine if the edible oil is adulterated with some of the non-edible oils or with the paraffins, etc. So we have to see whether the oil is adulterated or not. So we have to be very careful. There are a lot of edible oils, there are non-edible oils. Non-edible oils may not kill you, but they are the cheap oils, and then you can use them. For example, mixing 1 kilogram of, let's say, castor oil to about hundreds of kilograms of this, that will save at least 1 kilogram is saved. So I don't know, mineral oils, paraffins, very cheap. So if they mix it with that. And India is one of the richest countries in essential oils, flavors and fragrances. This industry is flourishing in India, and we have something like menthol, which is one of our main things that we distribute. We are good in attar, we are good in many things, and that gives a lot of cash crops there. And also in medicine we use these things. Menthol is very much used, L-menthol, in the medicines. And when you synthesize these things, you get D-menthol and L-menthol, and we have to separate them using chiral column chromatography. Chiral HPLC. And that is how you do separation of that. You get chirality columns also, and that will be presented during the HPLC talk. So the essential oils and perfumes and flavors are extremely important, and India is one of the strongest countries in that. And you will see many of the foreign companies who are in this business are all present in India. Whether you call it IFF or Simrise or many other companies, they are all present in India because India has got some of the best starting materials for this industry. In fact, I must be very happy to share with you that India is one of the richest countries in flora and fauna. We are blessed with the 3 sides of India is covered with sea. Can you imagine that? We are blessed, and we have got Himalayan mountains. We have got all the flora and fauna. No country in the world. I think I have visited many countries, but we have got all types of weathers. We have all types of rivers. We have all types of seas. We have all types of mountains. I don't think you can find any country in the world with such vast flora and fauna, and we are very rich. We have to be extremely conscious about it. It is our responsibility to preserve it, and it is our responsibility to make best use of it. Pharmaceutical value chain, you can get this slide from the internet. But the important thing is that at every stage of drug discovery, drug development, manufacturing, distribution, anywhere, you find a lot of chromatography. Distribution, especially if there is any complaint from the customer, it has to go back to the lab for checking. So at every stage, all the types of chromatography is used. And just seeing that, you can see drug discovery, all the type of chromatography and spectroscopy instruments are used. Bioanalytical, they use a lot of HPLC and LC-MS. You know, bioanalytical that we have to do. There are volunteers who are given these medicines. There's drugs which are under testing and the human trials. And we take electrodes of the blood once in a while and then test them and see the efficacy of the drug. This is a very important portion, and we'll be conducting a seminar purely on bioanalytical sometime in the coming future. Many students have requested to me, and I am looking for a good person who can talk to you, who is technically very competent on HPLC and LC-MS also. And quality control and impurity profiling. Today you can say the impurity, the compound is pure, your API or your pharmaceutical ingredient is 99.99% pure. Then people will call, what is that 0.01% impurity? You please isolate the impurity and identify it. So the things like that, HPLC with the photodiode detector becomes very useful in the identification of impurity. You can see the peak purity doing this, and that will be talked in the HPLC session. And when you are talking about the presence of heavy metals, in pharmaceutical industry, they use a lot of IC and ICP-OES and sometimes ICP-MS, because ICP-MS is a confirmatory technique. It can also detect at very low concentrations. Volatile impurities, API, this is where I said headspace and GC-FID. This is one of the methods in US pharmacopoeia, and this method is used for that. So this is where the headspace, I showed you the picture there in the laboratory, and that comes here. Headspace, GC-FID. Study of chiral compounds, I told you, HPLC is a very good compound with the chiral columns. You can separate the D and L, etc. And the biotechnology, when you are creating any of the antibiotics, insulin, or enzymes or whatever, you need them, and they work at a low temperature. You cannot heat them, so you will not use GC-MS, but GC or GC-MS, but you will use a lot of HPLC and LC-MS. And when they are in small amounts, you will use even nano HPLC. And these are type of experimentation that is instruments that are available to you today. Nano HPLC, capillary zone electrophoresis, an amazing instrumentation. You have to only know what application you need to do with which instrument, and if you have the instrument handy, then you can go to the space. We may have wished to go to the space, but if you don't have a spacecraft, it's very difficult to go. And that is the real predicament with a chemist who wants to really go places, who wants to do a lot of work, but if he is handicapped, not having the right instrument to work with, then he is in a very difficult situation. Drug trafficking, This is a big problem forensic scientists. I will dwell with on this slide for 2 or 3 minutes. And you will see drug trafficking is a big, it is punishable. So if somebody is carrying, let's say, cocaine or heroin or any of those type of compounds, morphine, etc., they are all punishable. And it is punishable, especially in a country like Singapore, if they have got 15 grams of the compound, active compound that they are carrying with them. If it is 15 grams or above, then the person is executed. But if it is less than 15 grams, let's say it is 14.9 grams, then he escapes. 14.95 grams, he escapes. 14.955 or 5 or 9, 14.99, he will also escape. But to that accuracy, you require with instruments such as GC-MS. It will go to that decimals of quantitation and it will tell you what is the concentration of that is present in that. So even if 14.5 grams of cocaine, let's say, is mixed with 1 kilogram of chalk, then after extraction, if it is only 14.5 grams, then the person really put into prison, but he is not executed. And this is the same thing, many countries have got this type of stringent laws against drug trafficking. And as you can see, a lot of heroin, morphine and heroin are in Afghanistan, and India is one of the routes that they choose in order to smuggle this out to other countries. So India has to be extremely careful to find out from our border what are the type of compounds coming into our country. These are the responsibilities of chemists and the agents and our customs agents and whatnot. And this is again, the people abuse the drugs. We have to take their urine or blood and we can analyze them. And drunken driving, which is a very, very big problem in India. And we find that anyway in a driver after 12 o'clock in the night, we have to be very careful, and that their blood contains alcohol. And the one way of determining that GC with headspace. So any forensic lab, including the Bombay one in Kalina, if you go there, you will find that there is a gas chromatograph connected to the HS with an FID detector. And you take the amount of blood and put into a vial and heat it, and then you analyze it. You will be able to quantitate the amount of alcohol, ethyl alcohol present in the blood. Document analysis, etc., TLC and other things are there. Suicide and homicide. If they take an overdose of a substance, let's say a pesticide, or let's say Valium, which is a psychotropic drug, they take overdoses. Then what happens is immediately chemical toxicology comes in. They take the body fluid or stomach wash, immediately go to the lab. We extract that and then do the analysis by GC-MS or LC-MS because we need confirmation, and an antidote can be given and the patient can be detected. Or even in a post-mortem, if the person is dead, we need to know what is the thing that they have taken, and the only case that is we can do is by this type of techniques, the confirmatory technique. To the court of law, the judge knows what is GC-MS and LC-MS. And if you go there and say that this contains this and that, he will tell what is the method that you use in analysis. So once you say that I have used GC-MS and LC-MS, he will ask questions about it. Please explain to me. And once he is convinced, then the case is over. If one has not done GC-MS and LC-MS, the judge will ask them to go back. Please analyze the samples and get back to me. And similarly, if somebody has dumped something in a river or in a rivulet next to their house or in a well, and you take out that water and analyze, again, if you want to file an FIR, you must see that you do a GC-MS or LC-MS. Arson is a very big problem. Inflammable liquid. Today you can watch TV. You can see what is going on in the United States. They burn so many places and they use so many inflammable liquids. So what are the type of liquids being used there? And one of the methods of main analysis is GC and GC-MS because they are volatile compounds. They are petroleum compounds. And from that they will be even able to find out what is the amount, what is the substance, and even they can, from markers, we can identify which petrol station they would have got it. Even in India, if they take it something from pump in a bottle, we can find out which pump would have given it, whether it is HP or Bharat Petroleum or some other one, because some additives, some configuration, some compositions are different for all these type of petrols. Terrorism, the big problem, the explosives. TNT and many other the explosives are there, and they use this in the bombs and all that, and these are very destructive, and this is where I said that our safety is very important. We want to live in a safe place. So I talked to you about really in the beginning an environment. We want a good environment to live in. Then I talked about the health. There are so many things that we need to test to see whether water is safe to drink, food is safe to eat, etc. Now comes to the safety. We don't want to live in an in a constituency or in a nearby school area where somebody is selling these drugs. We want our children to be safe. We want our youngsters to be safe. We wanted to make sure that it is not easily available to people. So we have to restrict that. And we have to support our government to make sure that we restrict these things, sale of these things. And these are the safe environment to live in. If our parents have to be happy at home, saying that my child is safe going to school and coming back, he is not going to eat a chocolate which contains some of these abused drugs, then it is a safety that I am talking about. That is the environment that we want to live in. So it is a very serious stuff. Chromatography and spectroscopy is a serious stuff. You cannot say I don't want to study it. You cannot say, oh, it is boring. You cannot say that it touches our life at every moment. Sports doping, very important. And here is the one thing where we have got all these sports people. You must be reading so much in the paper. Sports is a big occupation and a big business. But because it is a big business, everybody, the team manager thinks that his man should win the fight. His man should win the race. His man should win the match. So what they do is that they give some of the steroids and banned substances, etc., to the human being, to the sportsman, and he is not even aware about what he is taking. Because just before he goes to run, the manager may take this decoction. This is very good, and it will give you strength. And it may be already spiked with some of these performance drugs, which is very bad. He will win the gold medal, but later on the problem can happen that it destroys him because he will get diabetes and whatnot from the steroids. Ben Swanson case is very, very important. And during that time only, you can imagine 1988, he got the gold medal for sprint, but he was analyzed and it was containing stanozolol. So it was done by GC-MS in the United States using at that time a Hewlett-Packard instrument. And you can see I was involved with this lab much later on, but I know the lab which was analyzing all these things and the person who was in charge of the laboratory. Even we brought him to India to give help to how we can build up this laboratory. Okay, and now that is interesting thing I have to do is that the ex-director of this institute, Dr. Alka Biotra, has agreed that she will give a talk on the sports medicine. She's abroad now, but she has come to India on a visit and she has agreed that she will give a talk. So maybe next week I will try to arrange one on sports doping. She's one of the world experts, I can say. She works with the Olympics committee and she is one of the final words when it comes to sports doping and analysis of substances. So I want to bring that seminar to you sometime next week. Please sign up. Research, basic research, I don't want to tell you about CSIR lab, universities, defense labs, space research, VSCC and all that contains a lot of chromatography instruments. I was there in Trivandrum a few months back, met the research scientists outside, not inside, and they were explaining how much work they are doing, all the jet fuels and whatnot. They are really making pride for India. They are doing such research. We should be very proud. We are self-sufficient. We make our own jet fuel. We are one of the leading technology countries in the world. When I go visit many countries, I told them you are nowhere near India because India is far ahead. We have all the satellites, we have any type of thing that you take, whether it is shipbuilding, aircraft, guns, and whether you take tanks, whatever you say, India is capable of making them. So we are second to none. We have all the capabilities, and thanks to all the chromatography and spectroscopy that is working behind that. This is something, a very interesting thing, enzymes and this, that is many techniques are involved, especially in protein and peptides using LC-MS-MS. I will share a little bit of that on Friday, and ion exchange chromatography will be talked on Saturday. But many of the other things are very much present for peptides and proteins and enzymes, etc. And they all work under low temperatures, either room temperature or lower than that. And for that, the LC techniques and capillary zone electrophoresis and all the other type of things that have gel permeation chromatography. There are many types of different chromatography. Some of them are low pressure chromatographies. Some of them can be high pressure chromatographies. But there is a world out there to help the biochemist. There was a time when biochemists were not interested in chromatography or mass spectrometry. But today, none of the biochemists can really stay without doing LC-MS-MS in their work. Because that is one thing which helps them to find out what is the molecular weight, which is very important for them in their peptide analysis or protein analysis. This will be, to some extent, I will be covering on Friday. Estimation of some of the glycosylated sugar, vitamins, bilirubin in jaundice, all these things are, and then the organic acids, which are causing some of the deformities in the children, inborn deficiencies, that is done by GC-MS-MS. Lot of these are available in the literature if you go about it. So some of the vitamins, some of the glycosides, all these are based on HPLC, and some of our hospitals do have this type of equipments present. I know Nair Hospital has, I don't know how many hospitals, but some of the hospitals which have got these things, I know. But unfortunately, this is not being done in the Indian hospitals. I will take another 2 minutes or so, and I will close the lecture. And so they are not, but this is done very, very sincerely in abroad. If UK, if a child is born, they immediately take the blood and they determine whether there what is the type of organic acid, undesirable organic acid that is present in the blood or urine. So they do that test. And with that, I think my last slide, I want to thank all of you for your presence. I think you are really taken trouble. It is a lot of time to spend, and if you are spending the whole week, I know it is so many hours. But then our team is also very much on standby because we value your presence. This is given to you, and our all objective when you train each and every student or each and every chemist, our sole objective is fulfilled to some extent, and we have a thirst to give as many seminars as possible so that we serve the community that it deserves a very good seminars on chromatography and spectroscopy. With that, please send your emails if you have any questions, and we will definitely, there is a technical team that is behind this, and one of the members from the technical team will answer to your questions. Till that, you please keep flying high as the butterflies do, and in a very good environment, and be very happy and stay healthy. Thank you.